Okay, guys, the next group of lessons that we are going to do starts with 32. I know I'm skipping a few. That's basically what's going to happen till the end of the year. I know I have the next two groups already set up. I already told you about that. They're all posted on Haiku. So, we're skipping to 32. We're going to start to put a few things together, a few lessons together to get it ready so that we can do trig identities. So, today, we're going to talk about inverse functions. First of all, maybe we should talk about what is a function. What's a function?
Anything that goes on a number line. Plug something. Yeah.
No. A function has x's and y's. There's a connection. It's a relationship.
Like one input for every output or something like that? Other way around.
There's exactly one output for every input.
Oh, that's right.
Guys, remember we talked about our soda machines if they're functioning correctly. If I go down to the Coke machine and I push the Coke button, I better get a what? A Coke. You push it again, you get a Coke. You push it again, you get a Coke. It doesn't matter how many times you push the button, it should still give you the same soda. Now, if you push the button and it gives you something else, then we're upset, it's not functioning correctly. There we go. So, now, it says every one-to-one function has an inverse function that will let us go the other way. Now, we talked about what a function is. Now, a one-to-one function is what Stella said earlier, one input for every output. That means it's a little bit more exclusive, which means before it just be a function, I can have 2 go to a 3, I can have a 5 go to a 3. But every time I put a 2 or a 5 in, they have to then go to a 3. To be one-to-one, 2 can go to a 3, 5 has to go to something else. A line that has a slope, think of a line with a slope, okay? A line with a slope looks something like this, right? Every input has an output. Would you guys agree with this? Basically, it has this input and output. Put an x in, you get a y out. Put this x in, get a y out. Are they ever going to be the same? No. There's one-to-one. One input to one output. That means every input has its own and exactly its own output. That's one-to-one. If that situation happens. Now guys, do you remember the fact that to tell if this is a function, if I'm given a graph, all I have to do is the vertical line test. Then, to test if it's a one-to-one function, we do the horizontal line test. So we got vertical line test, horizontal line test. Those are all things you guys did last year, the year before that, and possibly I think we did that this year already too. So, if that is true and you can look at a graph or you're told this has an inverse, there's only 2 steps you guys have to know. Step number 1, switch x and y's. Step 2, solve for y. That's it. Technically, you would create the inverse function. Now, inverse function, guys, as we state here, if this is our original function f of x, its inverse function is f with a little negative 1 as an exponent, x. F of x. F inverse of x. It also says that either the function can be the original function, or the other function, or its inverse, can be the original function. Because they both are inverses of each other. One or the other can be considered the original, the other one be the inverse. So that's why we go to function notation and say f of x is our original function, and f inverse was the one we found, which is our inverse. So I got 3 problems here. I want you to find the inverse of all 3. We will do the first one together, and then I'll give you some time to do the others. First rule was what? Switch x and y. X equals 2y plus 3. Then, step 2, final step, solve for y. To get y by itself, what do? Minus 3, so you get x minus 3 equals 2y.
And then divide by 2.
Then divide by 2.
So then y equals.
So y inverse equals. Now this is something I'm not going to do. I will not leave it in this form. I'm going to separate and put in, because this is a line. If it's in our line, then I'm going to put it into slope-intercept form, which means mx plus b. So, would you guys agree that this would be 1/2 x minus 3/2? That y with the little negative 1 is y inverse. We also could call that f inverse of x. That's the inverse. Okay, I'm going to pause the video, give you guys a little bit of time to work on those next two by yourself, and then we'll come together. Okay, first step, guys. Switch x and y. So what does it look like?
Oh my god.
Subtract 5. So x minus 5 equals negative 2y. Divide both sides by. So y inverse is equal to, I switch the sides around, is that okay? Negative x over 2 plus 5 over 2. I switch the sides. I put y inverse first, so it's like y equals mx plus b.
It can be negative 1/2 x, right?
Yes, it can be negative 1/2 x. It's the same thing as negative x over 2. I divided the negative 2's go. I divided the 2's. Right? They disappear. Negative 2, negative 2. Next one. X equals 1/3 y minus 2. Then x plus 2 equals 1/3 y. Get y by itself. Multiply both sides by 3. So y inverse equals distribute. Boom. The negative 1 represents that one is the inverse that you found. Yes. I would like to see that. Okay. The first part was just for information. We needed to get that out of the way as well anyways. But this is why I'm choosing these lessons. The next 4 lessons have to do with still trig information. Sine, cosine, tangents. This time we're talking about inverse cosine, inverse sine, and inverse tangent. This is important. Because when we take the inverse of a trig function, you are not trying to find ratios, you are finding angles. So all inverses of trig functions are only relations and not functions. So therefore, if I tried to do the vertical line test, they don't pass. They don't pass the vertical line test because they have parts that are layered. They're on top of each other. If you think about it, sine, cosine, and tangent exist in all 4 quadrants. They exist from, anywhere from sometimes up to a 1 to a negative 1. And if I take the inverses, I can go in a positive theta direction, negative theta direction to get those ratios. So what we do is, because these are continuous functions, they never stop, we generally try to only take a domain and a range that is helpful to us. So this first slide is giving us what an inverse cosine, inverse sine, and inverse tangent look like. I'm going to say it, most of the time, you are going to see it as cosine with a little negative 1 on it. Inverse cosine. This is inverse sine. Inverse tangent. If anything, we should put, well, you would take this of a ratio. So you're going to see something like inverse, like on our problem, arc cosine of 1/2. Our unit circle is going to come in very handy today. So what I want you guys to know is that inverse cosine is this cosine with a little -1 on it, but some books say arc cosine. And this book will use this. Arc sine, arc tangent. That just means the inverse tangent, inverse sine, inverse cosine. So, an example would be arc cosine of 1/2. Or, if I'm dealing with inverse sine, it's arc sine of 1/2. Or, it's arc tangent of 1. Now, the reason I'm choosing 1, because tangent doesn't equal a half that we like. It's not on our unit circle. What we're trying to do with inverse trig functions again is to find the angle that when you take the cosine it equals 1/2. That's what this is saying. Arc cosine of this of ratio of 1/2 is equal to what angle? What angles, when you take the cosine, give you 1/2? No, the last tangent is 1. 240? Okay. Now, I'm liking, which one? You said 240 and 120. One of those is correct. The other one is not. Okay? We heard 120, which is over here, 120. And we also heard 240, which is all the way around to here. Look at your unit circles. What's the cosine of 120? Guys, cosine is the x value. Where is an x value equal to 1/2? At 120, is that true? At 240, it's -1/2. So actually, 240 is not correct, but 120 is correct. Where's the other one? There actually are two. There are 2 times when cosine is equal to 1/2. 60. So guess what, guys? You would have to say theta is equal to 60 and 120. Now, unfortunately, this actually is not the only 2. Sine, guys, listen. Sine and cosine go on forever. Could I, guys, start at the positive x-axis and go all the way around, which is how far? 360, and then turn another 60, which happens to be 420. So 420 degrees, 420 degrees has a cosine of 1/2. I could do the same thing for 120. Go around the circle one more time, right? Which is 480. And I could keep going and going and going. There's actually an infinite amount of answers, and that's only going in the positive direction. I could start here and go backwards how many degrees to get to the 60? -300. So actually, the -300 degrees would also give us a cosine of 1/2. Same thing, guys, applies for arc sine and arc tangent, finding values on our unit circle. There's an infinite amount of solutions. Now, saying that there's so many or infinite many solutions, we don't want to deal with that. Right? I'd rather deal with one or two answers than to deal with infinite many. So this is what we're going to do. We want functions, because functions are defined, right? One output for every input. It makes our decisions a lot easier. So to make this happen, we tie each relation to the one positive and one negative quadrants of its ratios. Think of sine. Sine is always positive in the first quadrant, because they all are. And sine immediately is negative in the fourth quadrant. So inverse sine, or arc sine, is in the first and the fourth quadrant. If I limit arc sine, arc cosine, and arc tangent to two quadrants only, I will have functions, and I will have the ability just to list a positive, or one negative answer and be done. But when do we know to use this instead of all real solutions or all the solutions? It's based off of the A in front. Is it a capital arc cosine or a lowercase arc cosine? Arc sine. Arc tangent. So, would you guys agree that sine is positive in the first quadrant? Because all students take calculus? Fourth quadrant, guys, is a negative quadrant. I cannot get to a negative quadrant by going this way without going to another positive. So if I went 1 and 2, I'd have two positive quadrants. I would have to ignore all negative solutions, and we don't like it. Cosine. Cosine says it is in quadrants 1 and 2. Why is it 1 and 2 and not 1 and 4? What do we know about cosine in 1 and 2? In 1, cosine's and positive, and in 2, cosine is. So if in quadrants 1 to 2, I will span all values that cosine can be. And if we go to arctangent, it is back to 1 and 4. Okay? The domain for cosine and sine is a set of all real numbers between -1 and 1. The domain for tangent actually is all real numbers, because you can actually get numbers that get very, very large and very, very small with tangent, because you got a fraction. And when you divide a number by a very small number, it gets larger, and vice versa, it gets very small. Okay? So, we need to evaluate these guys. And so, make this a little bit larger so we can see it. There we go. I am not going to let you use your calculator for this stuff, because you don't need it. You have your unit circle in front of you now. We're talking about sine, and we're talking about arc sine. Is this big A or little a? So that means inverse sine will exist in which two quadrants? 1 or 4. The value or the ratio right now that we're taking the arc sine is square root of 2 over 2. Is it positive or is it negative? Positive. Which quadrant are we talking about then? We are talking about the first quadrant. So the question is, what angle in the first quadrant, when you take the sine, you get square root of 2 over 2? 45. So the answer is 45 degrees. That's it.
You just need 45 degrees.
That's it. Arc, sine, arc, cosine, arc, tangent finds angles. You take it on ratios, which gives us angles. You take sine, cosine, tangent of angles to get us ratios. We're going in the opposite direction that we did our last quiz on. Arctan. Arctan exists in which two quadrants? 1 and 4. So it's one of these two. The ratio's negative. Which quadrant am I in? I am down here someplace, I don't know, I'm just drawing myself an angle.
Okay.
What angle has that ratio? Wait a minute. That ratio looks kind of wonky. What should it actually look like?
Shouldn't be 1.
Shouldn't that be a negative square root of 3 over 3?
So isn't that just negative? Oh, wait, no.
Yeah, think about it. We don't actually have this on our unit circle.
Yeah, I know. That's why.
What is tangent? It's sine over cosine.
Oh, so that's sine.
But again, just look at all of our numbers. Where do we have square root of 3 and a 3 for sine and cosine? You don't.
So no.
Wait a minute. Wait. Let's think of this even further. Do we always see this as square root of 2 over 2? Have you always seen it this way? What was the other version of square root of 2 over 2? Oh, yeah. That was really square root of 2 over 2 is equal to 1 over square root of 2. We fixed it, right?
So wouldn't that be 1 over square root?
Yes. This ends up being arctan of negative 1 over square root of 3. That you might be able to find either on a reference triangle, can't forget those, or on your unit circle. Think of this. Remember, it's sine over cosine.
Oh, so it'd be a negative 1 over.
Where do you see sine being 1 and cosine being square root of 3? Where do you see that in your numbers? I got a question. Look. On our unit circle, everything is divided by 2, right?
Yeah.
So, if you divide two fractions and they both are divided by 2, the 2's will cancel. So which one of those, ignoring the 2's, which one of those points in the fourth quadrant has a 1 for sine and a square root of 3 for a cosine? Or 1 over 2
300.
square root of 3 over 2. Okay, guys, I'm going to ask you this. Is this okay?
Yeah.
Hold on.
Oh, wait.
Is that the same thing as the purple fraction? Because you're dividing both by 2, the 2's would cancel, right? Where do you see 1/2 for sine and square root of 3 over 2? 330. So the answer is 330.
Yeah, it was either 300 or 330, and you guys said I was wrong.
This is what it all builds up to. They're going to give you problems that are going to tell you, hey, take the cosine of some angle, and that angle happens to be the arctan of negative 3/5. I'm going to give you guys a hint. I could care less of what the angle actually is. Because the angle is a stepping point that I'm just going to take the cosine of. What this all comes down to is working your way from the inside out using Pythagorean's theorem by forming your own triangle in the right place. First thing you need to do is you need to establish where your triangle is going to be. Arctangent exists in which two quadrants? 1 and 4. It's a negative ratio. You are in which quadrant? You're in fourth quadrant. This is your triangle. That's theta. That's your angle. Who cares? Nobody does. But that's going to establish, now you can put your sides on. What's the ratio of tangent?
Tangent is sine over cosine.
It's sine over cosine, but it's also opposite over
Adjacent.
adjacent. What's your opposite?
Your opposite is the 3
And the adjacent?
is 5.
5. So 3, 5. Wait a minute. It was a negative 3/5. Where's the negative go? On the 3. Can you find the hypotenuse of that triangle? It's just r squared, or h. We want to use h. H squared equals 5 squared plus 3 squared. What's 5 squared?
25.
Wait, what is that? Is that 15?
Plus 9 equals 34. So h is equal to the square root of 34. The question is, you now know theta. Theta's right there. We have a triangle. Can you now tell me the cosine of that angle?
Yeah.
What's the cosine?
Cosine would be
What's cosine, guys?
stop. Wait, co-op. So,
over
so, R1.
No, I'm opposite. No, I can't do it in my head.
Adjacent over hypotenuse.
No hypotenuse.
Now, guys, we really should fix that. I'll let you guys do that by multiplying the top and bottom by square root of 34. Guys, try the next one, please. Same way. Arc cosine exists. What 2 quadrants, guys?
1 and 2.
1 and 2. But it has to be a positive ratio, so we're in?
So 1.
We're in 1. What was, this is theta, there it is. What's the ratio of cosine?
So wouldn't it be 1, 2, 3? So it'd be a 30.
It's adjacent over hypotenuse, so it's 2, 3. Gotta find y, right, or opposite. 3 squared minus 2 squared is
13.
9 minus 4, which is 5.
5.
So, square root of 5, guys, don't.
What are we doing about this?
What's the sign of theta then? Ignore this.
3 over 5.
No,
2 over 5.
no.
3 over 2.
What is sine?
Opposite over
Opposite. Square root of 5 over 2. Homework is page 231, 6 through 7, 13 through 15, and 23. Have a great day.